morning. Uh, my name is FAKHAR ABBAS. I'm Land Geophysics Manager at Fugro, based here in Dubai. And I'm a geophysicist, not a geotechnical engineer. And over the next 15 to 20 minutes, I want to ask you a question which I think our industry has been avoiding for too long. I've been asking this question to project teams across the region for years. And the honest answer, the answer that nobody wants to give out loud is not as much as we think. And by the way, this over here means all of your projects, all of your project sites. So we commission boreholes, we get logs, we write ground models, we make decisions, and we build. And sometimes, not always, but quite often, something is waiting for us in the ground which we did not expect. So the question is not whether boreholes are good. They are, of course, good. The question is whether they are enough. Let me give you an analogy that I think captures this situation perfectly. So imagine a country that wants to understand its climate. They install weather stations, 10 of them spread across the country. The data at each point is perfect. Temperature, humidity, pressure, accurate to 3 decimal places. Every weather station is giving us perfect reading. But what is happening between those weather stations? They're just guessing. They're making assumptions between those weather stations. Suppose a storm develops between 2 points and nobody sees it because between points they have nothing. Now, give that country a satellite, and suddenly everything changes. They start getting continuous data, not just at the weather stations, but everywhere else as well. And no anomaly, no gaps, everything is seen. And the key insight is the weather stations, they don't become useless. They become even better. They become the ground truth, the validation points. Your boreholes is the weather station, and your investigation program needs the satellite. Design assumptions, construction surprises, time and cost impact. This is a chain. And every project in this room has lived some version of that chain. We expect the ground will behave in a certain way, and the ground surprises us. And we pay for it in time, in money, and in reputation. These are not the numbers which I invented. These are well-cited numbers. And typically, less than 0.5% of a project footprint is ever investigated. Less than 0.5%. And 73% of projects face significant schedule delays. 9 out of 10 capital projects overrun on cost and on time. And cost of almost 17% of the projects inflate due to poor ground understanding. We have been accepting this as normal. This is not normal. This is a choice which we all are making. Here is the fundamental problem. Look at this cross section. 4 boreholes spread across the section. The data at each borehole is perfect. The layering, strength, lithology, everything is excellent. But look at this cross section between borehole 1 and borehole 2. The hashed zone, the question mark, nobody knows what is there. We are just interpolating. We are making an educated guess based on 2 points in a continuous medium. We can double our borehole budget. We can drill 10 boreholes instead of 2. And still, we haven't addressed the problem. Because the problem is not with the number of boreholes. The problem is the space between them. No matter how many boreholes we drill, we are still sampling isolated points in a volume of ground that is continuous and variable. The method has a fundamental limitation, and more of the same method cannot fix it. What if we can see all of it? Not just at the borehole locations, but everything between them. Continuously mapped in 3D. What would that change about the way you commission your ground investigations? About the decisions you make? And about the risks you carry into your construction? Ground IQ is how Fugro plans and delivers ground investigation. We integrate results of initial geophysical site screening with targeted validation boreholes to produce a single ground model and then translate that into engineering insights. We start with full-scale geophysical site screening of the project footprint and start getting the initial models within days without waiting for long durations. And then from there onward, we plan geotechnical investigation but targeted, not as per where our grid tells us, but where our geophysical model tells us to have a ground truth. And once that model is created, we move onward and translate that model into engineering insight, into engineering parameters. And let me assure you one thing. It is not geophysics instead of boreholes. It is geophysics making every borehole smarter. Remember the satellites? These are satellites. So these are autonomous seismic sensors being deployed on a site in the region. And whatever I describe is real. We have been employing ground IQ on multiple projects in the region. And today, I want to show you example of one of those projects as my case study. The project is a high-rise tower in Abu Dhabi, and the total footprint of the project site is 5,500 square meters. We deployed 600 autonomous sensors at 3 meter spacing, and we took active shots, active seismic shots, to get high-frequency data to resolve the shallow subsurface better. And we drilled only 2 boreholes based on results of geophysics and performed laboratory testing in those 2 boreholes. And we also performed 1 PS suspension logging in one of the boreholes. What you are seeing on the left is 5 days continuous listening of 600 autonomous sensors spread across the site. Every dot you are seeing was listening continuously to vibration of urban environment, whether that is related to construction, urban noise, or any other urban traffic, any other urban noise. And from that, we built this, a 3-dimensional shear wave velocity model covering every meter of the project footprint. And what you're seeing on the right is velocity extracted specifically at the borehole locations, and in comparison with the borehole geology. And if you look at the numbers, they are in good agreement, both geology and the velocities. Now, look at the left panel. This is the 3-dimensional velocity structure for the entire footprint of the project. The orange zone with velocities above 930 meters per second, this is your competent rock. Hard, stiff, reliable bearing material. And the green zone with velocities between 720 and 930 meters per second is transitional, is variable. This is exactly the zone which your design team, project team needs to know before they commit to any foundation level. And the top blue zone with velocities less than 700 meters per second is softer material. And we can see its thickness is variable. With conventional approach of 2, 5, or 10 boreholes, we would simply interpolate the top layer and would miss the variability of this top. Now look at the right panel. This is what happens when you integrate geophysical site screening data with targeted intrusive investigation and borehole lithology. Every layer, whether that is sand, calcareonite, siltstone, gypsum, mapped across the entire footprint. The borehole told us what each velocity zone is made of. And the geophysics told us where each of those material is extending across the site. Now, let's have a look at some engineering insights, some engineering parameters. So the left model is the 3D UCS model, rock strength everywhere, not just at 2 or 5 borehole locations, but everywhere, spread across the site. And the center one is the UCS isosurface, showing specifically the zones where rock strength is more than 2 megapascals. The zones suitable for foundation bearing. So your design team knows where the competent rock lies and where it doesn't. And the right model, 3D shear modulus model, gives your engineers the small strain stiffness distribution across the site, which is a key input for the dynamic and seismic designs. And also foundation level in reference point for geotechnical engineers that they can build on for static design correlation. And all of them spread across the entire footprint of the site. So everything I have shown you doesn't sit in a static report. It lives here on the ground IQ platform. And your engineers, your team gets live access to every model. They can rotate, change the color scale, adjust the ranges, and interrogate the ground the way they need to, not the way we choose to present. So the outcome of my case study in 3 numbers, and very important 3 numbers. 5,500 square meters continuously characterized. Every meter of the footprint mapped, modeled, and validated. And 2 targeted validation boreholes, specifically placed at the locations where ground truth is required. Not 10, not 20, only 2. And let me assure you, they were enough. And no unexpected ground condition encountered. And this last one, no surprises. So this is worth more than any number that I could put on this slide. I started by asking how much beneath this footprint you actually know. Now you know this is possible. Can you afford not to know? Thank you.
Thank you, FAKHAR, for your presentation. Really amazing presentation, which we see it now. And if you have any question from your side, yeah.
Good morning from my side. My name is Elias Michalis. I'm the second day's chairperson of the conference. Thank you very much for your presentation. It's not a question. It's something which I would like to share with all of you here and comes straight from recent experiences with Athens Metro Project Line 4. Tomorrow, I will show something on my presentation. We are in a situation now where a TBM, one of our TBMs, has stopped completely its activities because we are facing problems of continuing safely without having settlements on the surface. And I wanted to say clearly now that the lack of having all this combined geotechnical and geological information coming from boreholes and geophysics was the real cause of not being aware of the problems we're facing now. Now we're in the situations which we're progressing by investigating, but also by combining different type of investigations. Boreholes, definitely, in situ testing, laboratory testing, plus geophysics. My experience says that if you are in a position to make all this combination and actually understanding of what all these different type of investigations can show to you, you are very close as a geotechnical engineer to give a solution to the problem. This is my experience which I wanted to share with you. Certainly, Fugro leads in the area of investigation in this particular field. And of course, the quality of the information comes from the experience of the company which makes them. So this is my experience wanted to share with you. Tomorrow I will show you a little bit more of this problem, but I didn't want to stay without saying or practically emphasizing how important it is for the geotechnical engineers to rely on good quality information coming from different type of sources of investigation. Thank you.
Thank you.
Yes, sorry, I have a question. Good morning, everyone. I'm Hamza Al-Hashimi. Actually, we were discussing, or I was asking Professor Marinos about the geophysical importance and rock classification as well. So we agree on the importance of geophysics. But my question is two tails. We agree that no enough boreholes that can capture the whole picture of the site. But we do have local codes to formulate the enough boreholes per se, the local codes of Dubai building codes, Saudi building codes, etc. If anything went missing, if someone was following the local codes, are not they protected if they follow the required number by the codes? And we do rely on the interpolation. But one could argue as well that between the 600 nodes you have done, you have used also some kind of interpolation.
Okay, so your first question about boreholes, you are in better position to answer that question, whether your boreholes, whether you drill them at 10 meters or 100 meters, are they enough? Are you getting the complete picture of underground? So that question again lies with you. In our experience, you need to understand the ground better, completely, continuously, before making these mega structures, high rises, or deep tunnel, or any underground project. And the second one, yes, of course, there is small interpolation, but look at this way. So you drill boreholes, 50-meter interval, 100-meter interval, and as compared to those boreholes, when you are interpolating 100-meter or 50-meter or 1 kilometer, how much interpolation a 3-meter spacing nodes will have. So you can correlate both of them together.
Excuse me?
Okay, last one, please.
Okay, I'm Dr. Ejikeme from West Africa, from Nigeria. My question is, you started by saying how much of what's beneath the footprint do we know? So my question is, do you have a model after you've specified how many boreholes you're drilling, you've applied all geotechnical, geophysical?
Can you raise your voice a little bit? Yeah.
My question is...
No, can you bring the mic a little bit closer to...
Okay.
Yeah, please.
You started by saying how much of what's beneath the footprint do you know? So do you have a model? Do you have a model that will use and estimate how much you know? 99%, 100%, 80% at the end of your investigation to examine the percentage of knowledge you know? Do you have a model like that? So that after your investigation, you can say, I have 100% knowledge of what's beneath. You get my question?
Yeah, I understand.
Thank you very much.
And thank you for that question. This is a very big question which I always been asked. So we cannot put this in numbers. But again, what I was explaining to Mr. Hamza here, you have your boreholes, whether they are at 50-meter or 100-meter, and you still have a lot of gaps between them. You can double your borehole numbers, even multiply them with 4, still you have gaps between them. So instead of having those gaps, if you get a continuous picture and then integrated model with geotechnical, that will give you better information, better resolution compared to having isolated points.
Just I have a small point. Thank you really for your presentation. It will be useful, in my opinion, because at the end, you deal with owner, developers, and all this stuff. So using geophysics, for example, in the project you presented, how much we get reduction on pile, how much reduction in foundation, how much gets reduction in value. So showing, in my opinion, it's nice to show what you did, but it will be beneficial to have a real project. If I did it with boreholes only, if I did geophysics and I got all this information and what the impact on the foundation.
Yeah, thank you for that comment. And because I said I am a geophysicist, I don't want to go into geotechnical detail too much, but we have all that information available at our booth.
Yeah, thank you. And